begin our presentation today by explaining about airborne chemicals. Airborne chemical refers to chemical substance that presents in the air. And all these substances can be generated from various industrial processes and may remain suspended in the air, which allowing them to be inhaled by workers and also can cause them to harmful health effects. So there are three types of airborne chemicals that we should know. The first one is particulates, and the second one is gas, and also the last one is vapors. So let's go to the first type, which is particulates. So particulates are fine solid or liquid particles that are suspended in the air. They are usually formed through mechanical process, condensation and combustion. And also there are several types of particulate matter that we should know. The first one is dust. So dust is formed when solid materials are broken into smaller particles. For example, in construction site, form of dust. The second one is fume. Fume is formed when metal is heated at a very high temperature and when they cool down, it can produce a very fine solid particle. A common example is welding. So we should know fume particles is more smaller than dust, which can stay longer in the air. Next one is fiber. Fibers refers to particles that long and thin in shape. For example, is asbestos fiber. These fibers are hazardous because it can easily enter to our lung, but it's so difficult for our body to remove. The last one is mist. Mist consists of small liquid droplets that are suspended in the air. It usually produced from spraying process such as pesticide spray and also spray painting. So in general, small particles, as we know that dust are more dangerous because they can travel deeper into our lung and also even can enter our bloodstream. So there are two main categories of dust that we should know. The first one is inhalable dust, the second one is respirable dust. So inhalable dust, or we can know as PM10, which is particulate matter 10. These particles are less than 10 micrometers in size. Because of their relatively larger size, they are usually trapped in the upper respiratory tract, especially in our nose and our throat. So exposure into inhalable dust typically can cause irritation in our upper respiratory system, especially our nose and throat. So the example of activities that can cause inhalable dust is like food processing, agriculture, and also general construction work, like cutting wood, cement work, and also farming activities. So next is respirable dust, or we can known as PM2.5, which is particulate matter 2.5. So these particles are more smaller, which less than 2.5 micrometers in size. So from their small size, they are able to pass through our nose and also our throats and penetrate deep into our lung, especially into our alveoli, which place in our lung. So our alveoli are tiny air sacs in our lung, which can make the gas exchange occurs. So when respirable dust is reached this area, it can enter our bloodstream and affect other parts of our body. So from here, we can see that respirable dust is more dangerous because it is associated with chronic and systemic disease. So what we can conclude here, even inhalable dust in the larger size, it can just mainly affect in our upper respiratory tract, while respirable dust in the smaller size, it can reach our deep lungs and also our bloodstream.
Yes, gas may seem harmless because we cannot see it, but actually it can spread widely and pose serious risks to human health. First, gas mixes freely with air and spreads easily, which is gas is a state of matter that can mix freely with air and spread quickly in the environment without boundaries. Second, move based on atmospheric conditions. It moves depending on factors like wind, temperature, and pressure, allowing it to travel far and disperse over a wide area. 3. Difficult to detect. Most gases are invisible and sometimes odorless, which makes them hard to notice without proper detection equipment. 4. Potential health hazard. When inhaled, certain gases can be harmful to human health, especially in industrial workplace where exposure risk is higher.
So this is an example of gas in industry, which is carbon monoxide, sulfur dioxide, chlorine, hydrogen sulfide, formaldehyde, ammonia, and also carbon dioxide. So there are several places that we can find this gas. The first one is at factory, the second one is chemical industry, the third one is at waste treatment plant, and also the last one is at refrigeration system.
Today, I will explain about vapor as an airborne contaminant. Definition of vapor is vapor refers to the gaseous form of a substance that normally exists as liquid or solid at the room temperature. Vapor can remain in the air and may be inhaled by workers. Next, common source of vapor in industry include painting activities, the use of solvents such as thinner and cleaning agents, as well as petroleum and chemical industry. Then, physicochemical properties. There are several important properties of vapor. One of them is vapor pressure, which indicates how easily a substance evaporates. The higher the vapor pressure, the more vapor is produced. In addition, evaporation rates shows how fast a liquid turns into vapor. A higher rate will increase the concentration of vapor in the air. Lastly is density. Heavier vapors tend to accumulate at lower levels. Third, route of entry. Vapor mainly enters the body through inhalation. When inhaled, it passes into the lungs and then into the bloodstream. Lastly, health effects. The health effects of vapor exposure depends on the type of duration of exposure. Short-term effect may include headache, dizziness, nausea, and respiratory irritation. Long-term effect may include lung damage, nervous system disorders, and chronic health problems.
One type of airborne chemical that we choose are organic gases and vapors. For example, assessment 3 airborne organic gases and vapors. Our group carry out painting activities using a solvent-based paint as a study situation. This activity is common in industries such as automotive, constructions, and maintenance work. To assess the concentration of organic vapors in the air, monitoring was carried out using the NIOSH Analytical Method Manual, or we call it NMAM 1501. The method was chosen because it is specific to detecting organic vapors such as toluene and saline, has a high level of accuracy and sensitivity, and it is organized as a standard method in occupational exposure assessment. Some of the main equipment used in the sampling process are personal sampling pump, charcoal tube, which function to absorb organic vapors, flexible tube, and clip holder to place the tube in the worker's breathing zones. The sampling process begins by calibrating the pump to a certain flow rate, for example, around 200 ml per minute. Then the charcoal tube is connected to the pump using a flexible tube. Next, the device is attached to the workers in the breathing zone, which is around the nose and mouth. To ensure that the sample taken represents the air inhaled by the workers, the air will be pumped through a charcoal tube over a certain period of time, for example, for 8 hours of working times. Organic vapors in the air will be absorbed by the activate charcoal in the tube. After sampling is complete, the charcoal tube will be closed, labeled, and sent to the laboratory for analysis to determine the concentration of chemical.
Next, we will look at the sampling train for vapor. A sampling train is a device used to collect vapor from the air. The main objective of this experiment is to evaluate the amount of organic gases and vapors in the working environment and to ensure that the concentration is safe for workers. We move to the next part, which is equipment. The equipment used in the sampling train includes a low-flow air sampling pump, which is used to draw air into the system. Next is the solid solvent tube, which contains activated charcoal to trap vapors. In addition, there is a sampling tube holder to hold the tube, flexible tubing to connect all the equipment, and a bubble tube calibrated to ensure that the airflow rate is accurate.
Procedure. Pump is calibrated before sampling, which is before the sampling process is carried out. The pump is calibrated using a calibrator to ensure the airflow rate is accurate and stable. Second, air is drawn through solvent tube. During the sampling process, air from the surrounding environment is drawn into the system by the sampling pump through the tubing connection. Third, vapor is trapped in charcoal. The air then passes through the solvent tube, which contains activated charcoal, where organic vapors present in the air are trapped or absorbed by the material. The last one is sample collected and sent to lab. Finally, after the sample period is complete, the solvent tube is properly sealed and the sample is sent to the laboratory for analysis to determine the concentration of vapors present in the air.